Alright, moving on with the next section of the review. This is the graphing of polar equations. Lots of different things to think about with this section, so probably going to be the toughest part of the test. My guess, I don't know. I could be wrong. There's no time for everything. Let's see. Graph these following equations and provide the name of the graph. This question is coming up a lot. I would like for you to be able to name the graphs if it's a cardioid or a line or a circle or a limacon. Please be able to name the graphs. Alright, so looking at number 19. Very, very easy problem in disguise. It's r sine theta. Now, r sine theta, hopefully you remember, is equal to y. So rather than think of this as a polar equation, I'm just going to say this is the graph of y equals 5. And now I'm not even thinking polar, I'm thinking old school rectangular equations. And the graph of y equals 5 is simply a line that goes through y equals 5. So I would count up 5 units. 1, 2, 3, 4, 5. And I'll have a horizontal line going through y equals 5. And it will look like this. So there's the graph of y equals 5. I'll make that a different color. Green. So there we go. There's a graph of y equals 5. And I did say provide a name for it, and the name for that is a line. If you want to be cute, you can call it a straight line, but it's redundant. Alright, the next one, this one's a little bit tougher. Anytime there is addition in here, it's going to be either a cardioid or a limacon. If it's 2 plus a number, sine or cosine, or adding to any two numbers times sine or cosine. And the way I graph my cardioids or limacons is I make myself an XY table, or an R theta table, not XY. And this is where your unit circle is going to come in handy. So I have R and theta, and we will only plug in the nice cute numbers for theta, like 0 degrees and 90 degrees. And I am sticking with the degrees. But the mathematically of America may differentiate because I'm using gradients, but they can get over it. And 60 degrees. Oh, my cat just walked by and took off my microphone. Hey, there we go. Golly, stupid cat. Okay. So if I plug in 0 degrees and we're plugging it in for theta, I get 2 plus 3 times the cosine of 0, and the cosine of 0 is 1. So 2 plus 3 times 1 is 5. Then I'll plug in 90 degrees. Cosine of 90 degrees is 0. So 2 plus 3 times 0 is 2. Then I'll plug in 180 degrees, the cosine of 180. And you know, these are coming off the unit circle. So we're looking at these points where your coordinates are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And at 180, my cosine is negative 1. And 2 plus 3 times negative 1 is negative 1. Plug in 270, that's down here, your cosine is 0. 2 plus 3 times 0 is 2. And 360 is the same angle, it has 0 degrees, so that'll be 5. And graphing this one, move my y-axis over some. I'm going to plot these 5 points in the 0 degree direction. I'll go 5 units. So 1, 2, 3, 4, 5. In the 90 degree direction, I'll go 2 units. So 1, 2. In the 180 degree direction, we go negative 1, which actually means I'm going to go this way. 1 unit. 270, I'll go 2 units. And 360, we're back to where we started. And this one is going to be a limacon. With a loop. And the way I know that is because I have these 2 points on the right side of the origin. So it's going to come up, go through that point. It actually does go through the origin, even though we didn't plot a point there. It goes through the origin. And the tip of the loop is that second point on the other side of the y-axis. So this point right here tells you the tip of the loop. This is a limacon with a loop. Okay, let's move on. Number 21, 3 sine 4 theta. This is a rows graph. This is a rows, and I know that because it's a number times the sine of a number theta. And the general form for a rows is r equals a, and then it can be either sine or cosine. feet theta. So with the rows, I need to know how many petals there are. And the number of petals is determined by this number right here. If it's even, you'll double it. So that means there are 8 petals. And I need to know how long each petal is. And this number right here tells you how long each petal is. So each petal is going to be 3 units long. So each petal is 3 units. Let's see, if there are 8 petals, I will do 360 degrees, and I'll divide by 8 because all 8 petals divide evenly around the circle. So that ends up giving me 45 degrees. And let's see, and the first petal for side is raised off the x-axis by an angle of 90 degrees divided by whatever that number in front of theta is. So 90 degrees divided by 4 ended up being 22.5 degrees. And so there I have all the information I need to graph this. So I'll graph my y-axis, my x-axis, and I will sketch 22.5 degrees. So here I am at 0. I'm just guessing 22 is going to be about right there. And it doesn't have to be exact, just ballpark it. So 22.5, and then I will move out 3 units in that direction. So 1, 2, 3 units. That's the tip of my first petal. So the first petal is going to come out like this. And each petal is 45 degrees apart. That's what 360 divided by 8 told me. So each petal is 45 degrees apart. So if I moved 45 degrees more, 22 plus 45 is 62. And that's going to put me somewhere up in here. And what we're going to end up having here is 2 petals in each quadrant. We are supposed to have 8 petals. And I told you I'm going to be very lenient with your graph. If you get that first petal right and the other petals are just remotely close to right, then I'll be okay with that. So this rose graph is going to look something like that. Very ugly, but it's a rose graph that has 8 petals, and that's what I want to see when you graph it. And make sure that it's obvious you went out 3 units. Put 3 little tick marks right there. Show me how far you went. Let's see. Yeah, this one's going to take a while. I thought it would. Let's see. I told you to skip 22. 22 was a bad one, so just make note that this was intentional. Maybe I'll move this down. Hang on just a second. So skip number 22. Alright, 3 plus 3 sine theta. This looks a lot like number 20, where it was 2 plus 3 something. So 3 plus 3 sine theta. I'm going to make that r theta table again. I'm going to go a little bit quicker through this one. I'm going to plug in my angles for r. And I'm going to pull the values off the unit circle. So I'm thinking unit circle. At 0 degrees, my sine of 0 is 0. So 3 plus 3 times 0 is 3. I'll plug in 90 degrees. Sine of 90 is 1. So that would end up being 3 plus 3 times 1. 180 degrees, sine is 0. So that's back to 3 plus 3 times 0. 270. Sine of 270 is negative 1. 3 plus 3 times negative 1 is 0. And then 360 degrees completes the circle and puts me right back at 0 degrees. So those are my points I'm going to graph. Let's see. I need to leave, I don't know. Let's see, I'll just graph it centered. That's pretty close to centered. Let's graph those 4 points. 0 degrees, I need to get 3 units. 1, 2, 3. 90 degrees, I need to go 6. 1, 2, 3, 4, 5, 6. 180 degrees, I need to get 3 units. 1, 2, 3. And 270, I need to go 0 units, so I'll actually just stay in the origin. And then we finish back at that same point at 360 degrees. So what this one's got to do, this is actually going to be your cardioid. Have a point at the origin, and that's where this thing's going to have a little point tip thing. It's going to look kind of like an upside down heart, or more entertainingly, looks like a butt. So there we go. And that is a cardioid. That is spelled wrong. Cardioid. There we go. 2 I's in it, by the way. It's cardioid. Let's see, 24 4. Okay, same type of situation. A number plus a number times sine or cosine. I'm going to create that r theta table again. So r theta, I'm going to go through this one even quicker than the last one. Plug in 0, you'll get 6. Plug in 90 degrees for theta, you'll get 4. Plug in 180 degrees for theta, cosine of 180 is negative 2. So 4 minus 2. Plug in 270, cosine of 270 is 0, so that would just be 4. And back at 360, we're back where I started at 6. So let's plot those 4 points. Let's see, it looks like I go a lot of units out to the right towards 0 degrees. And I need to move 6 units towards 0, 2, 3, 4, 5, 6. 6 units towards 0, 4 units towards 90. 2 units towards 180, so I'll go 2 units this way. And 4 units towards 270. And then we finish back here at 360. This one is going to be a limacon. It's going to come out at that point. It's going to come a dimple right there. And this is called a limacon with no loop. You have a limacon with a loop, and you have a limacon without a loop. This is the one without. 26. This is another rose graph, a number times sine or cosine, and then a number times theta. So this is a rose. The number of petals. This is an odd number, so that tells you how many petals there are. If that number was even, you would double it. So there are 7 petals. Each petal is 4 units long. And then if there are 7 petals and I spread them out evenly, 360 degrees divided by 7 is going to be, I want to get a good number for this. Let me punch this in a calculator. Okay, so that's going to be approximately 51 degrees. So pretty close to 50 degrees. We just think in terms of 50 degrees for the purposes of this graph. So each petal is 51 degrees apart. If it is a cosine graph, you don't have to worry about how far that first petal is raised up. When we go back to that sine graph I did a minute ago. This one, if it's a sine rose, you have to do this 90 degrees divided by the coefficient of theta to find out where the first petal is. It's kind of a pain. But if you have a cosine rose, then the first petal always goes right out on the x-axis. So I'm going to go 4 units out on the positive x-axis. So there is my first petal. And then I need to spread my petals out about 50 degrees. So my next one's going to go out towards 50 degrees, which will be up here-ish. Another 50 degrees would be around 100 degrees, so that's just after 90. Another 50 degrees would be about 150, so that's going to be about here. Another 50 degrees is 200. It's going to be about here. And then I have 250, which will be about here. And then I have about 300, which will be about here. And that's what this graph is going to look like. I want you to spread out all of the petals about evenly. So there you go. How many more graphs do we have? Good. We have 3 easy ones, and I think this is it. All right. R equals 5, negative 5 cosine theta. 2 ways you could think of this. You could think of it as a 1-petaled rose. It is a number times cosine, a number theta. However, the easier way to think of this is that it is a circle. This is just straight memorization. If it's a number times either sine or cosine, then this is a circle. I associate cosine with the x-axis. So when I graph this circle, I'm going to go through the origin. This kind of circle does go through the origin, and it's negative 5 cosine. Cosine I associate with the x-axis, so I'll go negative 5 on the x. 5 units out to the left, and this is what the circle looks like. It goes through the origin, goes out negative 5 on the negative x-axis, and there we go. So that's what this looks like. It is a circle. R equals 3. That is another circle. R equals 3 is a circle with radius 3. That's kind of what the R stands for. So I'll simply go 3 units in all directions. 1, 2, 3. 1, 2, 3. and I'll connect those 4 points. And there's your circle. Zone is also a circle. Number 29, for sine theta. That looks eerily similar to number 27, doesn't it? Yes, it does. The only difference is this is number times sine. I associate sine with the y-axis because on the unit circle, the y-coordinates are sine. There's a lot of things that correlate sine with the y-axis and the y-coordinate. So this is going to be a circle that goes up to 4 on the y-axis. It's positive 4 times sine, so I'll go up to positive 4 on the y-axis. Come down through the origin, and this circle looks something like that. So we have 3 circles to finish out all the graphs. So lots and lots of different things to think about with regards to graphing, and for that reason, this is probably going to be the tougher part, because you tend to get involved with theta and confuse the bit over the graphs of polar equations.